Alright, so in this clip, we would like to begin with the Maya fluid components. So our main focus will going to be the most basic structure that Maya fluid is made up of with respect to the elements like the emitters and helps in modifying the properties of the Maya fluid components. Alright, so first I would like to begin with the containers. So fluids are created only inside the limited domain of the fluid container. So that's a very important, statement. The most important section, or you may could say, the the home of the fluid is the fluid containers. Well, you may could easily interpret the word container. That means some sort of a storage house. Well, this is the localized version of the storage house of the Maya fluids. All the fluids will remain inside it. The fluid just cannot escape the containers, or you may could say the fluid cannot exist beyond the limitations of the containers. So one of the limitation is that it's actually not a limitation, but you can say it's a property that the fluid always do exist inside the containers. Now when the word container comes, we would like to interpret it through geometrically is that they are basically the three-dimensional cube which is made up of voxels and fluid emitters. Now the reason why I'm using the term called as a three-dimensional cube, just why? Because once you get the chance of creating the fluid, contained inside the Maya, you're going to notice that by default they are always created in the form of a cube. So what is a cube? Basically a three-dimensional, object that has all the sides equal. So that's the reason I would like to call this as a cube. I could use a term called as a three-dimensional cuboid, or I could say that it's a rectangular component, but it's not like that. Once you click the create button, Maya will going to create the default as a three-dimensional cube. Alright, and that three-dimensional cube is made up of the voxels. Now there's a very interesting and very important term is coming over that is called as a voxels. For those who need some refresh, voxels are, you may could say, as the volumetric pixels. And if I would like to talk about the pixels, what exactly is the pixels? Well, in a more simplified statement, the smallest dot in the computer graphics is called as the pixels. Pixels are basically also called as a picture element, that they do have their locations, specific locations, positions on the XY grid, and they also do contain the unique color ID through which you can interpret the values of the RGB colors or also the alpha. Alright, but the pixels are the 2D elements, whereas in terms of the voxels, they are the three-dimensional, you may could say, the volumetric pixels. And since they are staying inside the container, so each unit of the XYZ grid inside the fluid container is called as a voxels. So if it comes to define the word only voxels, you may could say that voxel is the individual unit of the XYZ grid of the 3D fluid containers. Alright, voxels are basically the DNA of the fluids that stores the values of all the density, fluid, or I could say, density, velocity, temperature, fuel, color, etc. That simply means that voxels are basically responsible for the look and feel of the fluids. Alright, let's just go ahead a little bit more. As I've already discussed with you, voxels are defined as the volumetric pixels which has the XYZ dimensions. Alright, voxels can store the values of density, velocity, temperature, and fuel. Now it will be a little early to describe these four important words, but we may could take with a very small example that if we are trying to simulate the fluid effect that is called as a smoke simulations. So you may could interpret the term density, which is the look and feel property of the smoke. The smoke is traveling upwards because of the velocity it carries in itself. Due to the temperature, how fast the smoke will going to rise upwards is the property of the temperature. And if there is some sort of the fire in the bottom section of the smoke, that means the fuel has added to the overall reactions. So till now, I can define these very, very important four elements of the fluid: density, velocity, temperature, and the fuel in a very simplest form. Alright, but don't worry, we have a detailed sections for the density, velocity, temperature, and the fuel, so just don't worry about that. Alright, let's go ahead with the voxels again. So voxels are always created and distributed under containers in square form. As you may could interpret it from the first statement that the three-dimensional cube which is made up of voxels. So voxels are basically the cube. So we have already stated that a cube is a geometric figure that has got the all sides equals. That means it's composed of six squares, simply speaking. All right. So, and it's a good thing that voxels are always created and distributed under containers in square form. However, you do have the provision to scale them, but that is absolutely not recommended. All right. So if we're going to talk about the production standards, we cannot manually scale the XYZ of the fluid containers. However, if you wish to increase the segment, you do have got the particular, XYZ dimension listed. Once we get a chance to work upon the Maya fluids in practical, you'll get the chance to see that yes, we could change the values of the XYZ dimension inside the container, and from that cube it will going to convert itself into a cuboid. All right. And you may also think of the, you could say, a comparison like that. If you have an image inside the Photoshop, you try to pull it off from the x-axis or the y-axis, it tends to be get stretched, because the point to be noted here is that the pixel aspect ratio inside the Photoshop for the pixels is always a square pixels. That means the x and y always do have the same pixels. The sides of the pixels always remain to be the same. So that's why it's called as a square pixels. So in a similar way, the voxels are also be treated as a square. Last we have is that the voxel density or voxel distribution, that is called as a resolution. If again you would like to take the example from the Photoshop, once you begin with the document or page setup, it always asks you in the bottom that the resolution of the page, sometimes you leave it to the 72, sometimes you leave it to the 100. For the print purpose, we always go for the 300 dpi, that stands for the dots per inch. So in a similar way, the more voxels we have inside the container, the better will be the resolutions. More clarity inside the fluids you're going to see, more rich in the details, but at the cost of computational, you can say, the additional processing of the rendering as well as the simulations. All right. So this is how we would like to end up the clip, by stating the meaning of the voxels and the fluid components. So if somebody will gonna ask you that what exactly is the Maya fluid composed of, answer should come in a way like that. Maya fluid is made up of the localized container, and the fluids are inside the limited domain of the fluid containers. No fluid component can exist outside the containers. The fluid component is made up of as the voxels. Voxel is basically the individual unit of the XYZ grid of the fluid containers. It can store the values of the density, velocity, temperature, and it should always prefer to be in the square form. And voxels can never be considered or treated individually. Voxels are always considered in, you can say, as a group, or I could say voxels are always considered with respect to the neighboring voxels, because individual voxels cannot do anything. It's always the composition of the voxels that the container is composed of. All right. So I'm leaving one thing here, that is called the fluid emitters, that I would like to address in the next clip. So taking pause over here, see you in the next clip, where we will be covering the aspects of the fluid emitters. All right.